talking about geometric sequences and series. So the first thing we need is this formula for the nth term. So we have that the nth term equals the first term times the common ratio raised to the number of terms minus 1. And we're going to use that to solve most of our examples. Okay, so for our first example, we're going to be writing an equation for the nth term of each geometric sequence. And we have this first sequence, which is negative 0.25 to negative 16 and 128. So first off, we know that the A1, the first term, is negative 0.25. And we know that the common ratio is how much we're multiplying by each time. Because of the sign change, we know it's a negative. And then I'm just going to pick the two that are easiest for me to tell. Like, I know that 2 times 8 is 16, so it should be times negative 8. So again, I can check that. Negative 0.25 times negative 8 is 2, times negative 8 is negative 16, times negative 8 is 128. So negative 8 is our common ratio. So R equals negative 8. So then we plug in, so we have AN equals A1 negative 0.25 times negative 8 raised to the n minus 1. And on this type, we actually stop here because that negative 8 has to be raised to the n minus 1. So until we know n, we can't do anything else. On our next example, instead of being told the sequence, we're told a specific term and then the common ratio. So we have the R, which is great, but we need A1. So right now, A3 is 16, which means that the third term is 16, meaning our n would be 3 as well. So we're going to plug this in to help us find A1, and then we won't use it anymore. So we would say AN, which is 16, equals A1 times 4 to the n, again, because this is the third term, n is 3, minus 1. 3 minus 1 is 2. 4 squared is 16. So 16 equals A1 times 16, which we can divide. And 16 divided by 16, A1 is 1. So R is 4, A1 is 1. We plug it in like we did here. So A sub n equals A1, which is 1. Again, that's understood, but I'm going to show it for the purpose of you understanding how to fill this in. Times R, which is 4, to the n minus 1. And notice again, for that final answer, I'm not plugging in A3 being 16 or the 3 for n. We just used that to help us find the A1. So the point is to write an equation. This is what the equation should look like. So the next thing we're going to be talking about is geometric means. And just like arithmetic means, they're just the terms between two non-consecutive terms of a sequence. So our question says to find 4 geometric means between 0.5 and 512. So I always like to set it up first. So 0.5, and then it says 4. So 1, 2, 3, 4, and 512. So we're trying to find the 4 numbers between 0.5 and 512. Well, what we know is that this is A1. So A1, and then 2, 3, 4, 5. So that's A6, and that would mean that n is 6. So we need to plug in A1, AN, or A6, and 6 into our original equation because we got to find that common ratio so that we can multiply and keep finding those blanks. So AN, or A6, is 512 equals A1, 0.5, times R raised to the n, 6 minus 1. Well, I'm going to go ahead and divide the 0.5. So if you take 512 divided by 0.5, it should double it, which is 1,024. So we have 1,024 equals R to the 6 minus 1 is 5. Now, we need to take the 5th root of that. If you don't remember, whatever that number is, you push 5, and then math 5 gets it to move right there. So then we type in 1,024, and our answer is 4. So R equals 4. So we're multiplying by 4 each time. So 0.5 times 4 should be 2. Let's go ahead and show this. 0.5 times 4 is 2. Times 4 is 8. Times 4 is 32. 8, 32 times 4 is 128. And then you want to check it because times 4 should give you 512. So 512. One thing just to pay attention to is because it is possible to have geometric means that change signs, you would want to check. So if this was positive, this would be negative, positive, negative, positive, negative. Well, 512 is not negative. So these are the only 4 possible answers. Where if 512 was negative, let's say, again, that's a pretty good hint because you have a positive and a negative to tell, but you could just test that every time. So whatever the sign is, just do the opposite, 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 opposite. And if it's possible, then you would just put plus or minus on those few every other ones. A geometric series is the sum of the terms of a geometric sequence. We talked about this with arithmetic series in our last lesson. So again, we'll use the SN and it'll just have some new formulas for us to look at. So these are the 2 partial sum formulas. We'll use them pretty much very equally. You're just doing them differently based on if you know N or AN, because you have to have A1 for both, and you actually have to have R for both as well. So you choose which one based on if you need N or AN. So for our first example, we're going to be finding the sum of the geometric series, and we have A1 is 2, N is 10, and R is 3. So since we know N, we're going to choose to use that top formula. So we're going to plug in SN equals, we have A1, which is 2, minus A1, 2, times R, 3, raised to the N, 10, over 1 minus R, 3. Now you could go ahead and plug that all in at one time to your calculator. That'd be perfectly fine. So we're going to get a fraction. We have 2 minus 2 times 3 to the 10th over 1 minus 3. So you could just type that in all at one time, and you get 59,048. So again, this is a sum problem. So the sum of the first 10 numbers, starting at 2 being multiplied by 3, is 59,048. For our second one, this time we have A1 is 2,000, AN is 125, and R is 1/2. Since we have the AN, we'll use the second formula. So we plug it in, SN equals, A1 is 2,000, minus AN is 125, times R, 1/2, over 1 minus R, 1/2. So again, we can plug that into our calculator. So math right up, that'll give your fraction, 2,000 minus 125 times, you could use 0.5 here, but since I've written 1/2, I'll show you that you could use 1/2, but again, 0.5 is fine. Again, on the bottom, 1 minus 1/2. So you just type it all in, and our answer is 3,875. So the sum of the first n terms from 2,000 to 125 is 3,875. Okay, for our next problem, we're finding the sum in sigma notation. So we're just going to type this in like we did with arithmetic. So you go math, and you go up to sum. And again, I like to use x just so I can be consistent. X equals 4, 12 is on top, and then we have 1/4 times 3 raised, again I used x, I gotta use the same letter, whatever letter I used, x minus 1. So all of that goes in the parentheses that it gave you. You could use the multiplication dot instead of that little parentheses in there. It's just my preference. And then you push enter. And so our sum is 66,426.75. And that will be your answer. So that's the only one of those we're going to do because I actually don't ask you to do a lot of these on any quizzes or tests, but I did want to show you that you could still use that sum button if you see it for geometric as well. Okay, for our last example, we're going to be working backwards to find A1, and we're told it's geometric, which is helpful, but we have the SN, the N, and the R. So since I have N, I'm going to choose this formula. If they told me AN, I would use that one. So we're using this top formula. So SN, we can plug that in, is negative 26,240 equals A1, we don't know, minus A1, we don't know, times r, which is negative 3 raised to n, which is 8, over 1 minus r, which is negative 3. So we're going to have to do parts of this by hand. We can use a calculator to help a little bit. We're going to have to do it by hand. So one thing is 1 minus minus is plus positive, and then we need to put negative 3 to the 8th in our calculator. So negative 3, I'm going to put that in parentheses, raise it to the 8th, and I get 6,561. So I'm going to rewrite this. So I have negative 26,240 equals A1 minus. Now, this was multiplied by A1. What's really important here is, I've seen this a lot, don't cancel these out. This one is being multiplied by this number, which was 6561. So minus 6561 A1 over 1 minus minus is plus positive, which is 4. So now to solve, the first thing I'm going to do is I'm going to multiply by this 4 and get rid of that. If I do it to one side, I have to do it to the other. So negative 26240 times 4 is negative 104,960. And then I have 1 A1. Again, you can put a 1 there if you want to, if that helps you. But you have 1 minus 6561. So 1 minus 6561 is negative 6560 A1. Then we'll divide on both sides, and that will give us A1, which is what we're looking for. So negative 104,960 divided by negative 6560, and our answer is 16. So A1 is 16. Again, the most important thing on this problem, where you're going to make the little mistakes, is remembering to do it step by step. So one thing, which again, I see this a lot, A1 minus A1, you want to cancel. Do not cancel, because this A1 is being multiplied. So make sure you multiply it, and then if it helps you, write that 1 in right there to help you remember to subtract. Because again, even on this step, those don't cancel. They're like terms that you need to subtract. So again, our answer for A1 was 16, which is what we were asked to find A1.